So in this video, given the sigma notation, can we actually find the sum? So part A says find from 0 to 3 of k cubed. B, sigma, the sum from 1 to 4 of 12k minus 8. Part C, the sum from 1 to 4 of k plus 1 over 4k minus 3. And part D, the sum from 0 to 4 from 3k plus 2 minus from 0 to 4 of 3k minus 2. Part E, from 1 to 5 of k squared minus 1 to 5 of 6k minus 9. Okay, so part A. So writing out the terms is a very good tactic when doing this type of question. So we put 0 cubed, and then the next term will be 1. You go up in integers, 1 cubed, next one will be 2 cubed, and final one will be 3 cubed. Now we stop there because we've got to the top number. But you start here and you end here and you go up in integer values. So that gives you 0 plus 1 plus 8 plus 27, which will give you 36. Part B, 12k minus 8. Now there is a little cheat that you can do, which I'm going to show you later. But just writing out the terms first of all, so you've got 12 times 1 minus 8, plus 12 times 2 minus 8. So we started at 1, we're going to end up 4. 12 times 3 minus 8, plus 12 times 4 minus 8. So this now gives you 4 plus 16 plus 28 plus 40. If you're not sure, just slow the video down and check for yourselves. Just do the last one here. 12 times 4 is 48, minus 8 gives you 40. When we add those up, we get 88. Now, you might want to have considered doing this. That we notice here that there's a common factor of 4. And now, if we've got a common factor of just a number, constant, you can take it outside of the sum. So this will become 4 from 1 to 4 of 3k minus 2. So it will be 4 times 3 times 1 minus 2, plus 3 times 2 minus 2, minus plus 3 times 3 minus 2, plus 3 times 4 minus 2. So that would be 4 times 1 plus 1 times 1 plus 4 plus 7 times 10, which is 4 times 22, which is 88. Notice obviously we get the same answer whichever way we do it. Next one is a fraction. So putting the numbers in, we get 4, we get 1 plus 1 over 4 times 1 minus 3, plus 2 times 1, 2 plus 1 over 4 times 2 minus 3, plus 3 plus 1 over 4 times 3 minus 2, plus 4 plus 1 over 4 plus 4 times 4 minus 3. So that gives me 2 over 1, plus 3 over 5, plus 4 over 9, plus 5 over 13. And just using the fraction button on my calculator, got 2006 over 585. Part D, we got from 0 to 4 from 3k plus 2, from 0 to 4 3k minus 2. So doing the first one, we get 3 times 0 plus 2, because we're starting at 0 this time. 3 times 1 plus 2, 3 times 2 plus 2, 3 times 3 plus 2, plus 3 times 4 plus 2, and then we minus in brackets, make sure you put the bracket in, because it's going to be minus all of it. 3 times 0 minus 2, 3 times 1 minus 2, 3 times 2 minus 2, 3 times 3 minus 2, plus 3 times 4 minus 2. So that gives me 2 plus 5 plus 8 plus 11 plus 14 from the top, minus, keep the bracket in, minus 2 plus 1 plus 4 plus 7 plus 10 from the bottom term. Now, removing the bracket, minus 2 gives us plus 2, minus 1, minus 4, minus 7, minus 10, and that gives me 20. Now, there is perhaps a slightly easier way of doing this. So, note that 0 to 4 from 3k plus 2 and 0 to 4 minus 0 to 4 3k minus 2. Notice the numbers have to be the same in order to do this process. It's the same as doing from 4 to 0, 3k plus 2 minus bracket 3k minus 2. And that gives from 0 to 4, 3k plus 2 minus 3k plus 2. The 3 k and the minus 3k will cancel out, and we're going to just do from 0 to 4 of 4. Now this is a bit odd, although it says 0 here, we just do this 4 times. We just have to add this, 5 times from 0 to 4, so that's a 0 term. This is when it's 1, this is when it's 2, this is when it's 3, and this is when it's 4. And that gives 4, and this is when it's 5. So that gives when 20, which is the same answer we got the other way that we did it. Okay, although it seems a bit odd that you write 4 for 0. This is what you do. You write down 4 5 times. Okay, from 1 to 5 of k squared, from 1 to 5 of 6k minus 6. So k squared will be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. Minus in bracket 6 times 1 minus 9, 6 times 2 minus 9, 6 times 3 minus 9, 6 times 4 minus 9, 6 times 5 minus 9. So we'll just got that's going to give 1 plus 4 plus 9 plus 16 plus 25 minus, keep the bracket in, minus 3 plus 9 plus 15 plus 21. So that's going to give 1 plus 4 plus 9 plus 16 plus 25. A sign change, 3 minus 3 plus 3 minus 9 minus 15 minus 21, which will give just an answer of 10. However, we could have done this. So doing a similar thing as we did in the previous part, we could rewrite this as k squared, sum from 1 to 5 of k squared minus bracket 6k minus 9, close the bracket, which is the sum from 1 to 5 of k squared minus 6k plus 9. Now we might realise this is a perfect square, that it becomes k minus 3, i.e. we factorise this, so 1 to 5 of k minus 3 all squared, which means we would only have to work out 1 minus 3 squared, 2 minus 3 squared, 3 minus 3 squared, 4 minus 3 squared, 5 minus 3 squared, which gives minus 2 squared plus minus 1 squared plus 0 squared plus 1 squared plus 2 squared, which is 4 plus 1 plus 0 plus 4 plus 4, which again gives an answer of 10. Okay, so this has been a video to show you how to work out, given a sigma notation, you can work out the sum, and showing some of the techniques that you can use in order to make the problem a little bit more easier. Okay, I hope you've understood. Just one thing, make sure that the numbers are the same if you're going to combine the notation. I hope you've understood, and I thank you very much for watching.